Alrighty, Kaylin. Hi, I'm Miss J, and thank you for giving me this doozy of a problem. At first, I looked at it and I was like, oh yeah, quadratics, so simple. Um, and it is conceptually not too crazy, but it does require a lot of skills to finish this problem. So, genuinely, thank you for spicing up my evening with a problem that took a little more thinking the first time around. So the problem that you gave me says y equals negative 0.08x squared plus 1.6x plus 10. And the problem tells us that y is the number of tons of trout caught. And that, I didn't spell trout right at all, did I? Hello, algebra teacher. And that x is the number of years since 1995. And it also specifies, which I didn't think was important at first, but after doing the problem, I recognized was very important, that from 1995 to 2014, is when this model takes place. And it says from 1995 to 2014 because of what happens at the end of the problem. So that's a 19-year difference, and we're just going to keep that in mind later because it creates some interesting issues for us. So when were 15 tons of trout caught? That's the question. And we're going to use this question to our advantage. So 15 tons of trout. Well, we know that y is the number of tons of trout in our problem. Oh gosh, my .cam is just not wanting to play nice today. And so if y is the number of tons of trout, then we can replace y with number of tons of trout in my equation. And so what I'm going to end up getting, excuse me, I'm just going to change the light a little bit over here, is a equation where we replace y with 15. And so we say, okay, 15 tons of trout are caught, so y is 15, and we get negative 0.08x squared plus 1.6x plus 10 equals 15. Now, I want to be able to solve for x, and since I have a trinomial with x squared and x, I can't solve by just subtracting and dividing like I normally would in like junior high school math. I need to factor my trinomial to find the zeros of this quadratic. But I can't find the zeros if this isn't set equal to 0. So the first thing I want to do is subtract 15 from both sides so that I can comfortably find the zeros of my quadratic. And I get 0 is equal to negative 0.08x squared plus 1.6x plus, oh, not plus, this is minus 15, and 10 minus 15 is negative 5. Now, originally when I sat down to do this problem and just check that I could, Kaylin, I tried to factor this using factoring by grouping and using a traditional guess and check method, and I just found it particularly challenging. So I decided, what's another way to find zeros of a quadratic other than factoring my trinomial? I can use my quadratic formula. I remember my quadratic formula with a cute little rhyme my junior high school teacher taught me. I don't want to tell you how many years ago. So it was negative b plus or minus square root of b squared minus 4ac all over 2a. So he had told me there was a negative boy who went to a radical party where he saw a square boy get rejected, so sad it's negative, by 4 awesome chicks, and the party all ended at 2 a.m. So in order to use this formula, you need to be able to identify a, b, and c. Standard quadratics follow the form ax squared plus bx plus c. So a is always the plain number in front of x squared. So my a term is negative 0.8, negative 0.08. My b value is the number in front of x. The number in front of x is positive, because it's plus sign, 1.6. I'm using an uppercase instead of a lowercase. That's okay. But if you want to use a lowercase to be more consistent, that's probably good. And then c It's a -5, so I'm adding a -5, so my C value is -5. Now all I have to do is solve this quadratic formula. So I plug in my appropriate values. B is 1.6, so I get -1.6 plus or minus the square root of 1.6 squared minus 4 times -0.08 times C, -5, all over 2 times -0.08. Okay, to solve this quadratic, I have to simplify what's inside my square root first, because I'm following order of operations. And you can view this all as being inside a big set of parentheses. So I have to simplify what's in here first, then I can square root it. So I need to go through here and multiply these together. So 1.6 squared, I'm going to do in this step is 2.56, and 4 times -0.08 times -5 is 1.6. Lots of 1.6s in this problem. And then I'm going to simplify my denominator here too. You don't have to in this step, but I just like to. And so you get -0, don't forget your plus or minus, -0.16. Okay, and so I still need to simplify my radical before I can go any further. And so the next thing I'm going to do is 2.56 minus 1.6. So 2.56 minus 1.6, and you can't see my calculator to the side, sorry for the pause, is equal to, those make 0.96. And so I end up with the square root of 0.96 there. Oh, okay. We're almost there. So now we need to solve for the square root of 0.96. We're finally to that point. Square root of 0.96 is a pretty big number. It's 0.979795897. And I'm going to round it out about 4 places because I am obsessive about rounding. So I'm going to say 0.9797 is what I get when I square root that over -0.16. Now I need to add my numerator first before dividing, but I don't need to just add it. This says plus or minus, so actually I need to do 2 different things. The first thing I'm going to do is -1.6 plus 0.9797 over -0.16. And then the second one I have to solve is actually subtraction, because it says plus or minus. So my solution could be this, or it could be this. -1.6 minus 0.9797 divided by -0.16. Oh goodness, I'm going to need another sheet of paper. That's just crazy. This problem's insane. Stop. So we move on and we say -1.6 plus 0.9797 divided by -0.16 equals -1.6 plus 0.9797 is -0.6203 over, all I did was add those together, -0.16. So now all I have to do is divide those. So I'm going to divide 0.6203, -0.6203 by -0.16. And that gets me a positive 3.87685. You don't need that many decimals. Again, I'm just a little particular about my decimals is really all it comes down to. Okay. So we have that. Or remember, you have negative 1.6 minus 0.9797 over minus 0.16. So that's a potential x value. But this guy also could be our x value. So that's negative 1.6 minus 0.9797 is negative 2.5797. And that's divided by negative 0.16, which is equal to 16.12325. Okay, and that's another potential x value. And so what this is saying, since it's a quadratic and it opens down, is there are two places where our y value equals 15. Because that's what we originally plugged in at the beginning of this. Can you believe it? It occurs when x is 3.8, and it occurs when x is 16.12. And so actually, there's two different times where 15 tons of trout were caught from the lake. The first time that it occurs is 1995 plus 3.8, because it's been 3.8 years since 1995. And so that's approximately 1998, the end of 1998, or if you're rounding up, you could say it was 1999. I guess it just depends on your teacher. I would still say end of 1998 personally. And then if you have 1995 plus 16.12, so it's been 16 years since 1995 and a little more. 16 plus 1995 is 2011. And so at the beginning of 2011, 15 trout were caught. And so there are two different years where 15 tons of trout were caught, believe it or not. 3.8 years after 1995, so at the end of 1998, or at the beginning of 1999, whichever you want to call it, and then beginning of 2011. And so the next question that's asked after Part A, which, believe it or not, we're still here. Part B asks, do you think this model can be used to determine the amount of trout caught in future years? Well, the current year is 2020. And that what I would say is we know that this model is at a height of 15, at 3.8, and at 16.212 for x values. So my question is, when do we hit 0? When do we hit negative trout values? Because if it's around 2020, we can't use this model in 2021. And so what I want to know is, when do we hit 0? Can this actually be used for future models? What does this function look like? And so again, I'm going to go through the process of my quadratic formula. Plus or minus square root of b squared minus 4ac all over 2a. And then I'm going to plug in from the original equation. So negative 0.08 x squared plus 1.6x plus 10 gets me, that's a, that's b, and that's c. A is negative, b is positive, c is positive for this one. And so we find that we get 1.6 negative b, so negative 1.6 plus or minus b squared 1.6 squared minus 4 times negative 0.08 times 10 all over 2 times negative 0.08 We remember from the last problem that 2 times negative 0.08 is negative 0.16. This stays negative 1.6 as well, plus or minus 1.6 squared. We can remember from the previous problem is, oh goodness, where is it? 2.56. And so really the only thing that we have to calculate that's new here is 4 times 0.08 times 10. And so you get minus, and remember it's positive times a negative times a positive, so that's minus negative 3.2, which is the same as adding a positive. And so you get negative 1.6 plus or minus 2.56 plus 3.2. 2.56 plus 3.2 is 5.76 all over 2 times negative 0.08, which we just said was negative 0.16. And so we find that we are ready to square root. Square root of 5.76 is 2.4. That's actually very pretty. So you get negative 1.6 plus or minus 2.4 all over negative 0.16. And that equals two different things. When we add and then divide, negative 1.6 plus 2.4 is 0.8. 0.8 divided by negative 0.16 is negative 5. And so it has a 0 at negative 5. And then it also has a 0 at what? Well, just using reflection, the other one's probably... No, I'm not going to guess. It's okay. So negative 1.6 minus 2.4 divided by 0.16. So negative 1.6 minus 2.4 is negative 4 divided by negative 0.16 is 25. And so the zeros of this graph occur at negative 5 and positive 25. Why does this matter? Remember, these are still x values. And so if you think about this, logically speaking, and using a visual, this function is going to look like this. It's going to have a y-intercept here. It's going to peak somewhere over here, all right? And it's going to cross your axis at negative 5, and it's going to cross your axis at 25. This is important because remember, x equals 20, x equals number of years since 1995. And so 25 plus 1995 is 2020. And so the 0 of this graph occurs at the year 2020. So we can't actually use this graph to solve for future years, because in future years, years past 25, let's say 2021, okay, that's 2021, my graph is going to be in the negatives, and there's no way to fish a negative number of fish. So part B, no, this graph hits negative values after this year, after 2020, so it can't predict future fishing. Unless that future fishing is the lake is empty and we're putting more fish in the lake for some reason.